Hello everyone. In this video I am going to demonstrate data transfer between two Arduino boards using ASK modulation scheme. I am going to transfer 9600 baud data between the two Arduino boards. I am going to use 48 kHz carrier signal to modulate the data. So the data between the Arduino boards will be modulated using a 48 kHz carrier signal, and we will be seeing the results. So as you can see, this is the transmitter end. So in the transmitter end, here you can see Arduino Uno is transmitting data. You can see from the TX pin of the Arduino Uno, I am sending the data. So this is the 9600 baud data that is being sent. So this data has to be received by another Arduino Uno, and we will be seeing the results in the computer console. So as you can see here, this data will be modulated with a 48 kHz signal, carrier signal, and we will demodulate the carrier signal and we will be getting the final data. So data is the data is transmitted from TX pin, and here you can see there is an optocoupler. You can see, so this is an optocoupler. The optocoupler is receiving the data. The optocoupler is used to isolate the transmitter circuit and the modulation units. So here you can see the data is being received. You can see the LED is flashing. So the output of the optocoupler, here you can see this yellow wire is the same data waveform, but it is isolated. So basically this is the isolated data waveform, and this data waveform is fed to, you can see, this modulating circuit. So this circuit is going to modulate the data signal with the carrier signal. So you can see the data is coming and it is received by the pin number 4 of the 555 timer IC. You can see, so the 555 timer IC is wired as astable multivibrator mode as an oscillator. So the oscillator is designed to generate a frequency of 48 kHz. The output of this oscillator is coming from pin number 3 of the 555 timer IC. So the 555 timer IC pin number 3 is the modulated signal. So this modulated signal is coming here and it is fed to this envelope detector. As you can see, this is the envelope detector. I am going to show clear view of the envelope detector. So this is the Schottky rectifier. You can see this is the Schottky rectifier. So I am using 0.1 microfarad capacitor here and 400k resistors. Equivalent parallel 400k resistors is 25k. So this 0.01 microfarad capacitor in parallel to 25k, this is the demodulator. So I'll show you the circuit diagram. The output of the demodulator is fed to this op-amp signal regeneration circuit. This is the final signal processing circuit. So in the signal processing circuit, the output of this demodulator is fed to the unity gain buffer. There are two op-amps used here. One op-amp is working as unity gain buffer and another op-amp is working as a voltage comparator. So the output of this voltage comparator is finally fed to this optocoupler, and the optocoupler output is finally inverted with another transistor, and finally it is fed to Arduino Uno. Let us see the results. So you can see here I am receiving alphabet R constantly. I don't have any error in the signal. You can see constantly I am receiving alphabet R. Let us look into the waveform. So here you can see the waveform. So this is the output waveform received by the Arduino Uno, and this is the waveform after the demodulator. You can see, so you can see the waveform is very nice and the data is also receiving properly. So let us see the circuit diagram now. So as you can see, this is the circuit diagram. So in the circuit diagram, you can see data is coming from transmit pin of Arduino Uno. It is fed to the optocoupler MCT2E. You can see it is pulled up with a plus 5 volts coming from the Arduino Uno. I am having a 330 ohms current limiting resistor and an indication LED. And the output of this optocoupler is pulled up with a 10k resistance to the 12 volt DC bus. it is fed to pin number 4 of the 555 timer IC. The 555 timer IC is acting as the stable multivibrator, but basically it is the modulator. So this is the signal that is sent to the modulator. And finally, from the pin number 3, you can see this is the ASK signal, amplitude shift keyed signal, coming out from the 555 timer IC. So this signal is coming here and it is fed to this demodulator. You can see this part is the demodulator. Here is the Schottky rectifier, 0.01 microfarad and 100K into 4 parallel resistances, 25K equivalent resistance. So this is the demodulator. The output of the demodulator is fed to unity gain buffer to prevent overloading of the circuit. Finally, it is fed to the comparator. So this is the data comparator and buffer circuit. Finally, it is coming here and it is fed to another optocoupler, MCT2E optocoupler IC. So from here, this is an LED basically. So I have corrected the diagram. This is an LED, so optocoupler. It is coming here. It is inverted by SL100 transistor here. The data, then finally the data is fed to Arduino Uno receive pin. So this is how the circuit works, and this is the final circuit view. You can see. So thanks a lot. Thanks for watching.